Well, hello, everyone, and welcome to the December 2024 OpenZFS leadership meeting. Okay, so I think the first thing that we had on the doc to look at are some FreeBSD specific changes for DirectIO. Alexander, have you had a chance to look at those recent changes that Mark Johnson's been doing to move towards enabling DirectIO by default on FreeBSD?
No, there were some fixes that were clearly broken code, and those were fixed. There was one discussion that haven't ended anywhere so far, is to allow make pages read-only on FreeBSD. That would be nice to have to avoid all extra checksumming and all the workarounds that would make horror out of all this DirectIO. But that's not fixable on Linux, so maybe it's not a big priority. Another thing is that due to FreeBSD VFS specifics, there is a question whether DirectIO introduces more faults which VFS cannot handle directly. It has to return error back, throw the stack, and re-enter again, and that's a mess. That was discussed also with Mark, and I think he was going to take a look on that last I remember, but I haven't heard any feedback after that. Okay. So in this situation, it should be working. It should not be horribly broken, but maybe not exactly perfect still.
Yeah, he opened a new pull request earlier today to solve an assert that some testers were running into. I think they were running stress 2 or something on it and found some issues. But yeah, it's looking like we're getting much closer to being able to enable that by default. Okay, I think the next one is the stuff that you've been working on, Alexander, on the improving the prefetch for block cloning.
Yeah, it's targeted for block cloning, but it may, in some cases, help other workloads too, read and write, just less often. So the situation I'm trying to optimize it is when single I/O require several direct block accesses. Just for block cloning, it's more often, since we can clone up to 1022 blocks at a time. And since our indirect blocks of 32K can hold only 256 block pointers, it may happen that we start reading them one at a time without prefetch, and on a slow hard disk pool, it may take a lot of time. So what I'm doing is I'm initiating prescient prefetch for the last 3 blocks out of 4, so that we can read them in parallel. Sure, it would be nice if we could have asynchronous debuff hold, debut buff hold, whatever. But right now it's all synchronous, so it's this kind of workaround for that, in lack of better ideas. But its implementation is simple and should not affect much any existing workload, since it issues prefetch only for blocks after the first. So most workloads won't prefetch anything. So I don't see issues, but if somebody could take a look, would be nice. Otherwise, on block cloning files on hard disk pool, I can see double performance increase for block cloning, which sounds good.
Yeah, Rob, I wonder if this might still be applicable even to the other workload we saw with the very large single file on NVMe. And when we're reading it in kind of small pieces, I think the record size is 16K. But it's like a 5 terabyte file. And so when we're kind of reading it randomly, there's a lot of indirect blocks. And you have to prefetch smarter with that.
I think in most cases you would wait only for, you would read all the indirect levels at sequentially, but then the only thing you could benefit at the last stage of reading L1 blocks, if you're doing very large reads writes and you have very small block size. So yeah, it could potentially help. As I've told, it may help some read write workloads, just in much more rare cases.
Looks interesting. We'll take a look at that.
Thank you.
I think next, Don, for the async ARC teardown. looks like you've got Alexander's approval now. Is there anything more that needs doing in that pull request?
I don't think so. I don't know if Brian was going to look at it or not, but I think it's ready to go. Last I checked, I think Alexander had one more comment, but um, in general, it looks like it's good.
Yeah, I commented one after I approved, so you should take a look on that comment. I have no other objection, at least I had no. So unless
Okay.
Brian wants to, or somebody else wants to take a look and object, I think we could push it.
Great. That one's a very nice feature for improving the speed of an export by letting a lot of the teardown happen after the fact, so that especially in HA failover type scenario, you can start using that pool again on the other system once the export's done, and you don't have to wait for all the memory cleanup.
On our systems, we just kill the system after 5 seconds of trying to export, but maybe we could not kill it in some cases. So yeah, it would be good.
Well, and especially in the case where you have multiple pools, it's, combining this with the previous work Don did that allows us to, with George's help, to export, multiple pools at a time. So when a server has 3 or 4 pools, being able to export them concurrently and take care of the memory cleanup after the fact can make a big difference. But especially in the case where you want to keep some of the pools on this machine, but export others, it can really speed things along.
Yeah, sure.
Doesn't look like Tony was able to join us today, so I don't think we have any update on the special allocation class stuff.
Last I remember, at least of my feeling, I got stuck somewhere in discussion of what considered special in light of our discussion on Dev Summit.
Yeah,
I would like it to be following after that, be implemented or in parallel. Otherwise, it looks somewhat hackish to me. It could be done in parallel and then reworked later, but I'm not exactly fan of that.
Yeah, I think to your point, that kind of figuring out what the different versions of special and so on look like, so that, and having that settled before trying to design it will lead to a much cleaner design. So maybe we can circle back to that one at the end if we're out of time, or if we don't run out of time. So Marius's pull request for scrubbing all the changes since the previous completed scrub looks to be in good shape now. It's improved, and I guess Brian yesterday was just waiting for CI to run against it again, and it looks like it has completed. So hopefully that one can get merged, and we'll circle back to some of the other parts of that series of changes, including scrubbing single files, and eventually looking at being able to scrub an actual date range rather than a transaction range or whatever. The next one I'm really excited about is Don's hackathon project that he showed us all last month. Don, you want to talk a little bit more about that?
Yeah, I finally got around to cleaning it up, and the code was kind of hacky at the hackathon, but and I even added, when I was looking at man page the other day, I saw like, yeah, they have nice edges in there because Unicode, so I put those in there as well. But yeah, it's working there. I had to work around the like RAID-Z one. Every once in a while they flip the columns, which breaks the rule of like things go in order. And trying to think what the last one. There's a couple of small things I fixed, but I think it's looking pretty solid. So hopefully people will take a look at it and try it out, see if it works. I've tried it on all the RAID 1, 2, 3, and kind of different types of files.
I haven't looked on it, but I wonder, does it support multiple VDEVs? I think it would be interesting just to see general fragmentation or layout pattern between VDEVs. And if it would also support mirrored, which should be quite easy, I think.
Mirrored would just be the 2 disk. It would be identical going down.
Oh yeah, but in some cases I would just from perspective of optimizing allocator or I don't know fragmentation analysis, something like that. It would be I think interesting to see general picture.
Yeah, the distribution is, I mean, people think it's sequential and, you know, increasing. It's not, because if the allocator needs to go back up, it will, and your file could be, you know, kind of scattered around. But yeah, for multiples, yeah, that's a challenge. The same challenge for DRAID is like there's only so many columns of data you could put on the screen. So in that one, I don't know if I could say you could flip between the two or something. I don't know, but I'll have to think about that. The D-RAID, I was thinking to just having it very dense, where you just have PD, D1, D2, you know, it doesn't have any data, but it just shows you how it got dispersed. But certainly multiples.
No, I'm thinking one of the next projects to try to optimize how we distribute data between multiple VDEVs, depending on how much filled they are. And in that context, seeing how much do we write on each between switching between them would be nice. Or I worry that right now, if we are getting a full queue, no, like allocation limit by allocation throttler, whether we actually continue this distribution after or start pushing here and there randomly and creating some terrible mess.
Yeah, I mean, I think it's round robin, and then we factor in the response time, so you get one can get more. You could put more. You can land more on one, or less on one. It's more accurate, I suppose.
No, yeah, less. But question again: after we fill in all the queues, we have one ZIO completed. Doesn't mean we will allocate one on random disks, and one more completed. We'll allocate one more, who knows where, and it all turns into some mess.
Yeah,
it would be good to still continue full blocks through each. That would be nicer. But if right now we are allocating, filling holes, then that's worse situation. I worry about that. But again, no, I'm thinking dive into that, but haven't yet. Hopefully soon.
Yeah, for that, I'm thinking like what we do for flame graphs, where you would actually put out the data and have somebody process it, because 80 columns or whatever we're kind of limited what we could show there, but we could show it a lot denser if we did something like flame graphs or something, use that technology maybe.
Yeah, I can see where that'd be useful to kind of just look at a byte range on a disk and see how like all the bits in an allocation. So you can, you know, like when we're looking at the 16 megabyte allocations and the padding and so on, how are those packed end to end nice and clean, or is there a bunch of little 4K allocations stuck between them and so on? And the stuff we were talking about, possibly looking at preferring certain meta slabs for different sizes and so on. So yeah, I think there's a lot more that we could do with what Don started here.
Yeah, this was a start just to help me. It was for some other project, but it's helpful as a start, I think. And then yeah, we could hopefully spurn other ideas out of this one.
Yeah, and like I think there's a lot we can get out of what you've already built here. But then yeah, even just more ideas and more ways to actually see how our theory matched up to what it actually did.
Yeah, this is a start, but yeah, we have a ways to go because it is complicated. Like Alexander referred to, if you have multiple top levels and yeah, all kinds of stuff going on.
Cool. The next one we had is another FreeBSD one. There's a file system flag called unlink. So normally ZFS already supports the system unlinked flag, which says that only root can remove this flag that says you're not allowed to delete this file. But there's an alternate version of FreeBSD of unlink that says the owner of this file has the ability to set and unset this flag. And ZFS doesn't currently support that, and they have a pull request open to resolve that. So it'd be good to get some quick reviews on that one. I don't think it's overly involved.
I commented on there, and it was considered as right now back to work in progress. The problem is with current implementation that it maps two bits into one. That just can't work. We would probably need to extend list of bits supported by ZFS. I don't know whether that's a problem or not, but there may be a few other bits aside of no-unlink that could be supported the same way. So it's maybe it's a good
I had
idea.
a list quite a few years ago of the flags that didn't work, but I've not looked at it since then.
I guess right now supported bits are all coming from Illumos, or they were added later.
I think it was just what was common with the Lumos at the time. But yeah, I know that there's a couple more that we could definitely do. Like I think you even identified the append-only one or something, right?
No, it wasn't my command. I think it's.
Oh yeah, that was NG's. Yep.
Yeah.
But yeah, we can have to look at how to do that and see maybe if we do something similar to what we do for the system attributes to have it be more extensible and store it in such a way that it's not an on-disk format change in order to have additional flags there. Okay, and then the next one was optimizing RAID-Z expansion. You made some changes there, Alexander?
Just recently there was some Trunas forum discussion about expansion being too slow. I went to look inside first time in forever, and I found it was generating pair of ZIO for read and write for each A shift. So 4 kilobyte at best, or maybe even 512 bytes. So performance was barely reaching 1 gigabyte per second for SSDs and much less for hard disks, like 50 megs per second. So I jumped into it and I rewritten the way we previously discussed it with somebody. I forgot, maybe Matt, maybe somebody else, that it should just generate ABDs for those granularities and do bigger IO. That's what actually I did. I allocate, I look, code was already looking for sequential chunks of data, and I'm just taking that, limiting to 16 megs or whatever memory limits is set, and then just allocate sequential buffers for write and tons of Gang ABD on top of that for read. So practically reads are writing into Gang, into buffers prepared for write. Sure, it's a crazy mess of gangs and ABDs and everything, but overhead of that is much smaller than overhead of ZIOs. So with this code on SSDs, I was able to reach 6 gigabytes per second at 512 at a shift 9 and 12 gigabytes per second at a shift 12, or 500 megabytes per second on hard disk pool, which is also disk limited. So I'm disk limited in all the cases. No, there was a few other minor optimizations, improvements. And I hope I won't scramble user data, so I would appreciate somebody to take a look that everything works correctly. But yeah, I'm pretty happy with the results I see now.
Yeah, that sounds like a pretty big improvement.
There was some other ticket about expansion not properly reporting progress if you delete something during expansion, but I thought if we speed up expansion 5 times, that maybe we don't care what happens during expansion.
Yeah, it definitely reduces the amount you have to worry about it.
Alexander, do you think it's worth trying to get these optimizations into 2.3, or is it too late for that? Just because that's where expansion is hitting the public, or is?
No, again, as soon as people jump and review it, there are some things that would be nice to have in public. From other side, we already have RC4. I don't know how many RCs do we plan. Honestly, I haven't asked Brian how much RC does he plan, but we're still collecting smaller fixes here and there. Like from time to time, working on block cloning. I'm catching some block cloning issues here and there and fixing them. So those obviously should go into 2.3. While this we may import later after, like 2.3.1 or something. It doesn't burn, but again, as soon as it's...
I think so too. But yeah, you might have gone, no, this is so much better. We would definitely say that's good.
Yeah, especially it's nice that when for shift 12, when we have ABD matching page size in combination with fixes later to Linux VDF layer, now it can really avoid any block copying, memory copying at all. I haven't tested on Linux, I've tested on FreeBSD, but idea is the same. If as soon as everything page aligned, I can, sure, in profiler, I can see a ton of CPU time spent on ABD allocation and free, but there is no memory copies and or anything like that. So it should be pretty fast. Maybe we could invent some even fancier ABD types to avoid allocation, or maybe just allocate them in a bunch as sequential memory ranges as we do for inside RAID-Z somewhere, I think. Not for expansion. That could help a lot, but since we already can do 12 gigabytes per second, I'm okay about it for now.
Yeah. Rob, do you want to talk a little bit about the changes you made for Slack compression and where you are with that?
Yes, I can. That's a good reminder. So Slack compression is a compression format that just doesn't do anything. It just looks for the trailing set of zeros in the block and really just changes the size. And this is a good once you get to like 16 megabyte blocks. Yeah. So I'm just giving a quick review for the
so the use case the customer has is using larger record sizes, whether that's 1 meg or up to 16 meg. The data is already encrypted, so it can't compress at all. So using normal compression doesn't really make sense. But if you have 16 meg records and then you have a file that's 36 megabytes, you're gonna have two 16 meg records, and then this 4 meg record that once you have multiple records rounds up to the whole 16 megs, and you're wasting 12 megabytes of storage space. When you do that times hundreds of thousands of files, that adds up to serious numbers of hard drives. So the idea with Slack compression is to be able to trim the trailing zeros on the last record in a block, or last record in a file, but without the cost of the normal compression mechanism that involves making a whole bunch of different copies and so on. And so I think that's where some of the enhancements you did came from, right, Rob?
Yeah. So it came out of that. So the very first one that I posted last year was like the most naive version possible, which did copy data that it didn't need to, because compression assumes that it's always copying into a new buffer. And then we did work making compression work on ABDs. So then I did an ABD. So this is what I've pushed into the PR last week before, is so like an ABD version of that. So iterating over each chunk. And then I've done a in-place compression. So we have a table of different compression types. You set a flag on that to say this is an in-place. Do you set a flag on that? It doesn't matter. And then it will compress into the same buffer. Obviously, this assumes that the compressor is capable of doing that. In this case, the API supports it, but obviously Slack doesn't do anything. It doesn't modify the data. It just returns a different size. But the point is it avoids all of those copies. And that, I don't have the number in front of me right now, but that gave like a noticeable performance bump, which you'd expect because we're not copying anymore.
Yeah, looking at what you have here, it looks like it was about 13% faster than LZ4.
Yeah, that's right. I haven't done my big, like the same amount of performance testing that I did on the original set yet. I just haven't had time for that. But I think that one is kind of a no-brainer, considering it doesn't change anything for the existing methods at all. And then the other thing I was looking at is if you have because basically the way to do Slack is you have to count from the you have to scan from the back of the buffer, rather than the well, you don't have to, but you want to find the last non-zero byte. So it's sort of is like, well, how are we going to do this? But you can't. It's harder to do that if you're iterating over chunks. So I wrote the start of a reverse iterator from ABD for ABDs that starts at the back. It's a little bit sketchy at the moment because they're not really designed for that. That didn't yield any obvious performance improvement in my very small tests, but I need to do bigger tests on that. So that one I'm less sure about. And then after that, and this is one that I haven't pushed it, is the Linux kernel has this so it's scatter gather buffers like struct SG list or something like this. And they have an iterator that rather than doing a callback, it's a macro over a for like a for loop. So each iteration around the loop, one of your control variables is just set to the current page or the current chunk, whatever. So I thought that's something I'd like, because I sometimes wonder about, not for this specifically, but just generally, I wonder about the overhead of calling the calling the callback for every single sort of chunk, and even just the code hassle of setting up setting up a struct to then pass down as an argument. And it's like it's stupid. Sometimes you just want to do it in line. So I've got a prototype of like a sort of an inline iterator that doesn't iterate byte at a time, it iterates chunk at a time. So by whatever the ABD considers to be a chunk, so whether that's a page or a compound page or a whatever, it just gives you some run back each time, and you go through it. But it's all in line. There's no functional stuff. It's all implemented as macros. So I'm going to be posting a prototype of that soon, which is implemented in terms of the old iterators, but if everyone liked the interface, we could replace the old ones with that. And you can have the callback based ones are written, like, work the same way. Can be made to work the same way. Just the ABD iterate func just has a for loop in it instead. So that's what I've been doing. So I was slightly unprepared, so I don't have anything just to point at, but yeah, I want ABDs to get much nicer. And fewer copies and all sorts of stuff. So I think there's lots we can do there. If anyone who wanted to look at the Slack compression based one, stuff of that, it's in the I pushed to the existing discussion PR for that, which is 15215. So I would appreciate comments on anything in there if you are so inclined.
It seems CI wasn't happy at all about it. It had some build issues. If you could take a look. It failed build on everything.
So look at that. Okay, yes, I will figure out what the hell's that's about. All right. Yes, I'll sort that out today then. Thanks. I hadn't noticed that at all.
So just for, sorry, I haven't looked on it lately. It's not about the last block, it's just specific compressions that compresses from the end. Just some more simplified version of generic ZLE or whatever.
Yeah, kind of.
Yeah, kind of like ZLE, except for it doesn't have to actually change the data at all.
Yeah.
Like, so that decompression, there's nothing to decode. It's literally just we set the physical size to the non-zero parts.
Yeah. One of the frustrating things about it, it's very much like there's a function ZOShrink, which does basically this, but it has a comment in it that says, this isn't safe for RAID-Z because it changes things. And we could do this, like leaving aside performance overheads, we could actually do this for everything. The problem is we need an indicator in the block to know that we have to undo the size change later. And that's convenient as a compress at the moment, but you could also imagine it like, I mean, I don't know if there's any compressors that don't know how to compress runs of zeros, but but you could imagine like you could have just another flag in the block pointer that indicates, oh, and all, well, not another flag because it needs another size, but something that says, oh, and also once you're done, fill the size back up to this size.
No, if the compressor could report at how much did it read, or no, did it write, then we could just fill everything, the rest with zeros. So then we could apply it to any compressor. If it just find, okay, we have half block of zero, compress the first and fill the rest.
I can't remember. I'll find it. There was a reason that something wasn't good with it. It might be that simple, and I just complicated it in the moment. I'll take another look. But yeah, but yeah, it's just done as a compression method at the moment, which I don't love, but yeah.
But now it doesn't apply to only the last block. You can compress anything in between too.
Yeah. And we did try just the last block, but the problem is by the time we get down that far, we don't actually know that it's the last block in a file. And I think I tried threading that through, and I think it wasn't clear because there can be multiple operations in flight and all sorts of stuff, multiple blocks being written in different places. And yeah, it was really hard to tell which was the last block, if there was a last block. I mean, now you're asking me to remember, well, you're not asking me anything, but you're asking me to remember stuff from about 18 months ago. So I'd have to go and find my old branches for that. But yeah, I mean, yeah, I don't know what the best way to do it is, but the idea is good. The idea.
Yeah, sure. Definitely any compression working on ABDs is great. I would be happy if we adapt more algorithms to that.
Yeah,
but at very least, having this maybe even by default or somehow more actively use it would be nice.
Yeah, I really would like to have a look at the chunked compression stuff, like, you know, the LZ4 and Z standard compressors can do
streaming
can do it
mode.
in parallel. We've just got to make stream mode, that's it, but we're just got to make sure that it actually produces the same result.
I think sadly it does not.
Yeah,
parallel obviously can't produce the same, but if just compressor could go block by block and properly address ABDs in process, then it would be nice.
Yeah, I mean, even avoiding those copies would be good. Not having to linearize up front, that would be really good.
Exactly.
That
so yeah, that's definitely something we should look for.
Yeah.
Did everyone else get locked out of the Google Doc? I was editing just fine before, and now it won't let me change anything. It says the file's read only.
Yeah, me too.
Okay.
I contact owner. Who is the owner of the file?
The quote public facing doc service account. I'm guessing at Delphix. File created in 2018. So might have to see about doing something about that too. Might change the link after. Anyway, I guess the other one, Rob, that you did recently was Zpool condense to do the on-demand flushing of the space maps, and then we were going to look at doing the same thing for dedupe and so on.
Yeah, this is what is it? It is
16747.
16747. I think where my understanding of where that's at is that it's just about figuring out like when asked to condense how much we do all at once, and you know, competition with other IO on the pool and that sort of thing. So it's sort of policy-ish kind of question, and it's a bit of the same kind of stuff we had to deal with the dedupe log flushing, and I think I'm avoiding it slightly because I really just don't want to do that again. It's not quite that bad. I mean, it's just like I don't want to just dump all the IO straight out because I don't know what else is going on the pool. But
Right, and like
we don't
Alexander
have
pointed
a
out,
yeah, exactly. But
But-
we don't really have a way to ever know what else is going on the pool. And as we add more and more of these things, and so I'm sort of at the point where I'm like, do I need to do something which is like every subsystem that has some stuff to flush out should actually like, you know, register it with some scheduler, and then that scheduler is going to tell it how much to do each time and that sort of thing. And then it's like, oh well, now I'm building infrastructure and glass towers, and maybe I should just do the damn thing. And that's the point where I stop thinking and go and get another coffee. So I don't know if I would appreciate any input. I will end up doing something. I'm not going to hold this up for too long, I think, but
yeah, to Alexander's points in the PR, obviously the users wanting to do this quickly because yes, even our use case for it is to prepare for a managed failover. So we're going to export this pool in order to do the OS upgrade or whatever. And while we're waiting for traffic to drain off, we're going to precondition the pool for a faster import on the other side. And kind of as we saw with the deletes with BRTs and the stuff that you looked at recently, Rob, that if we queue too much IO at once, we're going to use all of our memory on ZIOs and so on instead of actually managing to get some work done. So figuring out the right solution for this will make sense. And I think Don's already been looking at how to do the pacing on the dedupe front, and maybe we'll be able to kind of just reuse that mechanism, especially since this Zpool condense thing is also going to want to be able to condense the dedupe log in the same way.
Yeah,
I think just a slightly different side. Some time ago, we were discussing deletion throttling, and I think recently, while looking on dmute delete long range or whatever were the functions, I think I tripped again on some throttling there, that we have a limit how much we delete within one transaction group or something like that. So I don't think I found it last time. I wanted to mention it, but I tripped it later. But maybe we could implement just global how much dirty data we have or something like that.
Yeah, there was a global for the amount of frees we would do in each, what percentage of a transaction group could consist of frees or something. And I know it was pretty
like
conservative before, and it was tripping up Pudrere, the package building system on FreeBSD, where it was ending up being like unnecessarily slowing things down. But yeah, I agree that having, some control, but not a separate control for every kind of deletion and so on, might make sense here.
Yeah, maybe that's the way. Just extend some of the things that are already there. That one with the deletes, the reason that one didn't throttle the delete 2 terabytes or whatever is because it always allows you to add your first thing. So it lets you add the first 2 terabytes because you do that in one thing. You say, I want a free 2 terabytes. And it's like, okay. And then the next free comes along and says, I want a free 4 kilobytes. And it's like, nah, I'm over. But it's already accepted 2 terabytes. So that's why it didn't throttle that off, because it doesn't know how to break it down in any useful way. So maybe there's something to do there to make it a little more able to deal with fragments or something, How much could you take this TXG? Oh, this much. Okay, well, let's have that much. Or I don't know. There's lots that we do. Yeah, I guess the question is, do we want to do this now? Like I can design, I can build these things, but do we? At which point do we actually do them and then start building features on top of them? And I'm never sure if this one can, condense space maps. Is this the one that forces us to, build the infrastructure component we need? Or do we just get this there and build a thing? I don't, that's actually a question. How do we decide when to do this? Okay. Nobody
Yeah,
knows.
we'll have to think more about that. I guess, yeah, the last thing on the list, Alexander, was maybe, did we want to talk more about defining what is special and the idea of having some new type of property that's like a bit field or something where we can specify, you know, types A, B, not C, and D kind of thing?
No, yeah, as we discussed, it would be nice to have it, but I haven't thought about it later, especially in context of that special allocation class.
Mm-hmm.
But that PR would benefit from it since in some cases we do want to leak second copies of the data onto the main pool. On other cases, we don't. For example, if we're using special VDF just as faster storage, then sure, we can leak second, third copies of blocks. But if our primary storage is some huge D-RAID, then it would be counterproductive, and we should not do that. In that sense, it would be nice to have to understand what exactly is our special and when should we start leaking or not.
Yeah, I agree with that. And having that so that we can build the shared storage stuff, and then also having like a pool property or something that defines which types of special get this backup behavior or whatever, so that we can say, you know, it's D-RAID, so no, don't do it. Or, you know, it's we're okay with the slower writes, so, you know, do it for more types than the default or whatever. Yeah. And that gets back to Don's question from a couple of months ago. You know, when we have multiple copies of metadata, is there any way to make them not all born in the same transaction group, such that if something goes wrong with that write, that maybe the two copies won't be affected by the same problem?
We would have to spread them, keep some of them in ARC in dirty state to write them later.
Mm-hmm.
But if it will be only one copy, is there a guarantee it will not be corrupted in RAM and written later again corrupted?
Right.
Like I saw myself when I have mirrored pool and I have data corrupted on both, but it makes me wonder, was it a memory corruption before the write, or how
Before
else
the
could it
write,
happen?
Mm-hmm. Yeah, for
Because
sure.
I suppose even if it's single controller writes two different blocks, I doubt it would corrupt them identically same time.
Yep.
It could miss them both, not write them. But will it that write everything else, commit transaction, and so on?
Mm-hmm. Well, it's just also, you know, to try to mitigate the latency penalty of writing the metadata. You know, usually the point of having the special VDEV is that now your metadata is faster on both read and write. If we're backing up, writing a copy to the spinning disk as well, then it's only faster on read, in which case maybe a cache makes more sense. But if we could write the copy to the hard drives more asynchronously or something, so that it didn't slow down synchronous writes, then that might make that feature more interesting. But then it's a whole lot of, well, if we're allocating the DVA and claiming the space, but we haven't actually written it yet, and then things go wrong, does, you know, if we think we have a backup copy and we don't, that's not helpful either.
Yeah, but if we are writing a lot of data in some smaller blocks, it may still be beneficial to write them to main pool. Main pool may be faster if it's writing sequential, unless it's badly fragmented. It's quite easy to write to main pool. That's why I am a bit uncertain about usability of special dedupe device, because that dedupe device has to be really fast to actually dump dedupe table. It is the previous incarnation. Now with dedupe lock, it should not be that big of a problem. But we may have now that problem partially with BRT table. When each transaction group, you need to commit all the changes. And it may end up the problem that we are committing them in different times with other data, at least for dedupe. We're first writing normal data, then we're writing dedupe table. I actually haven't checked what's happened for BRTs. should be the same. We first write a normal data, and then we start writing BRT itself. And if we put them on different devices, it appears that we first only normal device is busy, then special device is busy, and then here,
Right,
there,
and
and
if
we
we
are
could
not
parallelize, then we would have a lot less waiting around, right?
No, yeah, but again, if our main pool is already big and fat and everything, it may have high latency, but it should also have pretty high throughput.
Yep.
At least I hope HBAs will grow. For my test system, I some time ago changed it to 12 gigabit HBA. Even so, I have 6 gigabit JBOD simply because it has faster PCIe. I'm not limited by bandwidth there, so I can pump more through that HBA. And yeah, it's still hard disk enclosure, but it's 60 drive, and I can pump quite a lot of traffic there.
Mm-hmm.
It can potentially compete, or at least get close to some NVMe single device special.
Yeah, definitely. And that's part of why we were so interested in the tiering stuff we were talking about at the Dev Summit, because in certain cases, it can make sense to have, the indirect blocks and so on, even in an all hard drive pool, but kind of focus to, a mirror of hard drives or something, where if we can get them sequential enough that you're going to get most of the performance without needing different hardware.
I actually wonder how indirect block writes are sequenced. I have feelings they will get intermixed with data or written in some not exactly convenient for reading order.
Well, that's what I was saying. If you basically had a special VDEV that was just a mirror of hard drives, so that it was only holding indirect blocks, might you avoid some of the intermingling you get. And then it also gets to Don's ideas of trying to dedicate certain metaslabs to just indirect blocks or something to help avoid some of the fragmentation you get when you mix really different allocations in the same set.
Yeah, up to some time, not so long ago, we actually were writing different indirect blocks into different allocators. So if you are writing single file, you have the chance to get indirect blocks in different allocator, different metaslabs effectively. But now with when allocators were rewritten, now we are writing each one file with one allocator. So they will get intermingled within same metaslabs probably.
Yep. But yeah, I think another place where Don's visualization tool might be useful is to see how did this stuff actually get laid out on disk in the end.
Yeah, my closest alternative was ZDB and just looking on block pointers for devices and offset. Not the most convenient, but the closest I had in mind. But I haven't got to that project. I need to at some point soon.
Yep. Did anybody have any other topics they wanted to bring up? No. Okay. Our next scheduled call is on January 7th. Slightly off our normal 4-week cadence, but I didn't figure we wanted to try to meet through the holidays. I'll see everybody in January. Have a good holiday.
See you.